Factoring. Think of factoring as FOIL in reverse. Let's look at an equation ax squared plus bx plus c. To factor this equation, find two numbers that multiply to c, but also add up to equal b. For example, let's use the equation x squared plus 5x plus 6. To simplify this, we need to find two numbers that multiply to 6, but also add up to 5. So let's take a look at the factors of 6. We'll start with 6 and 1. We already know that they multiply together to equal 6. But do they add together to equal 5? No, 6 and 1 are out. Let's look at the next set of factors. 2 and 3. Again, we know that they multiply together to equal 6. But do they add up to 5? Yes, they do. So we have our answer. Always use this format of two numbers that multiply to the last term, but also add up to the coefficient before the second term. Let's take a look at another form of factoring, the difference of squares. The basic from this looks like x squared minus y squared equals x minus y times x plus y. Let's take a look at an example. X squared minus 16. Now note that this looks slightly different than the basic form that we just showed. But that's because the y in this example has already been squared. So you have to ask yourself, what is the square root of 16? The square root of 16, as we know, is 4. If this was a larger number, you could use your calculator to quickly figure it out. So now we know we factor this as x minus 4 times x plus 4. Let's take a look at another example. A squared plus 2ab plus b squared. Now, because this equation doesn't feature subtraction, the answer is going to look slightly different. Instead of two sets of parentheses, one with addition and one with subtraction, we'll have a single term, a plus b, but it will be squared. So our final answer will look like this, a plus b squared. If you distribute a plus b times a plus b out, you get a times a, which is a squared, plus ab plus b squared, which simplifies to a squared plus 2ab plus b squared. Let's look at a similar example, a squared minus 2ab plus b squared. Now, because this one has subtraction instead of getting a plus b squared, we'll get a minus b squared. Let's take a look at a similar example using the integers x squared minus 10x plus 25. Think back to the example with letters. The only thing that has changed is that a is x and 2b is 10. It's also important to note the subtraction sign, meaning we know that the final answer is going to involve a subtraction equation inside the parentheses instead of addition. So we know 5 is the square, and we know x is the other variable, meaning we can simplify this down to x minus 5 squared. While it's not absolutely necessary to have your difference of squares down, it can save you valuable time during the test. Remember, if you know how to factor, you'll reach the answer even without simplifying to a difference of squares. The advantage is that it'll save you a step and a minute or two on your total time. Let's get into quadratic equations. By definition, a quadratic equation is an equation that has a squared term as the term with the highest power. For example, x squared minus 5x equals negative 6. You can solve quadratic equations. Think of this as one step further than factoring. To solve, just set the equation equal to 0. This will require getting everything on one side of the equal sign. And ultimately, have you heard of this one before? Isolating the variable. So let's stick with our example. X squared minus 5x equals negative 6. Our first step to solving this is to move the 6 over with the other terms. To do this, we'll add 6 to both sides, so we can set the equation to 0. X squared plus 5x plus 6 equals 0. Now we can factor the equation. Remember, we're looking for two numbers that multiply together to produce 6, but also have the sum of negative 5. Let's look at the factors of 6. Remember, a negative number multiplied by a negative number produces a positive number, so negative 2 times negative 3 still nets us a positive 6, but their sum is negative 5. Those are our factors. So we'll have x minus 3 times x minus 2. Now we'll set each individual equation to 0 and solve through. X minus 3 equals 0 and x minus 2 equals 0. Add the 3 and add the 2 and we're left with x equals 3 and x equals 2. And those are our answers. You may see quadratic equation questions written in a different way. mainly in reverse. You should be able to work backwards from the solution to find the original quadratic equation. Let's take a look at an example. For which equation is x equal 1 and x equal 4 the solution? So let's work with this one in reverse. We'll subtract 1 and 4 back to the left side of the equal sign and get x minus 1 times x minus 4 equals 0. Now we can FOIL these two terms. Remember FOIL. First, x times x, outer, x times negative 4, inner, negative 1 times x, last, negative 1 times negative 4. So that leaves us with x squared minus 5x plus 4 equals 0. And that's our answer. Let's take a look at an example problem. If x minus y equals p, then 2x squared minus 4xy plus 2y squared equals... We can start this one by factoring out the common factor, 2x squared minus 4xy plus 2y squared, which is 2. Doing this leaves us with 2 times x squared minus 2xy plus y squared. Hopefully you will recognize this result as a perfect square trinomial from the factoring differences of squares lesson earlier. Remember that these commonly show up on the GRE, so be sure to understand and recognize them. Using the formula, we can write our equation as 2 times x minus y squared. Looking back at the given problem, we know that p equals x minus y, so we can substitute it in and get our final answer, 2p squared.